Thank you so much, Richard. Hello, everybody. Just a quick note, secure should be in quotes. Not everything's secure, and we'll get to that. I really appreciate the opportunity to speak here today. Hackaday's been an institution for almost, I think, over 20 years now, since I was in high school. And last time I was in Pasadena was during a summer undergraduate research fellowship at NASA's Jet Propulsion Laboratory. My email is jose@source.parts. That's a real email address. If I don't respond, please ping me a couple times, and I'll try to help and navigate any issues that you may have or just have questions on. Let me be your guide if you need one and want to understand a little bit more about anything from buying parts to making things in China. So I moved to Shenzhen, China in 2018, and I've been there for 5 years. I've only come back to the United States maybe a few weeks at a time. And as such, my brain, in a way, is still thinking in the Chinese language. When I moved there, I did not know one word of Mandarin besides ni hao, xie xie, hello, thank you. Now I can go into a factory and do an entire factory tour in 100% Mandarin. And this is something that's achievable by being in China and immersing yourselves and speaking with people. And there, everyone, usually when I speak Chinese in China, people ask me, where did you go to school and learn Mandarin? I said, well, this is my school, and for how many people that are in China, those are how many teachers that will teach you Mandarin. So more than 1 billion people, they will spend a few minutes of their day to teach you how to properly say something. I just would like to say before I continue, just please don't talk or ask me anything about politics due to the nature of my work. And a disclaimer, I'm not advocating for violation of any copyrights or patents for commercial or personal profit. Information provided is for educational purposes only. Also, take what I say with a grain of salt. Trust your own judgment, do your own research. My life experiences are different than yours. If I say something wrong, please correct me. I would love to learn more. So personally, I was an engineer, electrical engineer in Oakland, California for some time before I moved to China. And as such, we interacted with manufacturers in Shenzhen in order to get things made. And right now, we're between 2 and 3 p.m. Pacific Standard Time here in California. In China right now, in Shenzhen, it's 15 hours ahead of here. So, in a way, I have to think of myself in 3 places at once, right now, but at different times. So, if someone was to come from Hong Kong, which we fly out of the airport to come here to LAX, you are literally traveling back in time. Because over there was tomorrow, some cases, and over here is yesterday. So you kind of see people yesterday. And then when I go back, it's going forward in time. Now, I say traveling is not really, it's the same exact time. It's just a different place on the Earth, and the Earth sees the sun at a different angle. One thing to note about 3 places. Let's say Europe, China, and United States. China is the center. I don't know if many know this, but in China, in Mandarin, China is 中国. 中国 is Middle Kingdom, translated directly. It's the Middle Kingdom between the East and the West. There are other ways to say China. Like Zhonghua, which means the middle magnificent or the middle kingdom. So when you speak to China, it's kind of like speaking into the future. Hey, it's the end of my day here in California. Tomorrow when you get up, I need you to do these things. And then when I wake up tomorrow, I hope those things are done. And I hope there's no problems in the orders that I gave you to get this thing made so I can get this into my customer's hand. So I would always like to remind everybody when speaking to manufacturers in China, do the thinking of them doing something in the future if you're engineering here in California. So Shenzhen, China is probably the world's largest manufacturing capital in the world. There's thousands of factories in what's known as the Greater Bay Area, which is Hong Kong, Shenzhen, and Macau. So we are endlessly constructing new devices, new items. And where do those items go? So it's this endless cycle of manufacturing and destruction. And we have new devices that take new space here on Earth. And there's endless possibilities for what those devices can do. Every year, companies like Apple and Google, they come out with new flagship phones. What happened to the previous generation? And is this new generation even more secure? Well, if you want to know if something's more secure, you need to destruct it. You need to destroy it. You need to reverse engineer and see every single part of it and how it works. Admiral McRaven, a Navy SEAL with 37 years, he was a bullfrog. He said, sometimes no matter how well you prepare, how well you perform, you still end up as a sugar cookie. It's just the way life is sometimes. And he said this in the context of a commencement speech. And this is meant as, it was told in part of a story. And an instructor tells a student to wear your best pressed uniform. Make sure there's no imperfections. It needs to be perfect. And then the student comes and the uniform's very nicely well done, but no matter what, the instructor says it's not good enough. And I want you to go into the sea and douse yourselves, wearing the uniform, douse yourselves in water, and then come out and roll around in the sand, and you end up looking like a sugar cookie. So this is a story about how to press on, is in choosing your battles so that you can win long term. And also, I like to think of this not just as in the military context, but also as humans and how machines like cell phones end up as sugar cookies. You buy a phone, you download apps, and you get updates to those apps, and poorly written code leaves all this little artifacts all over your storage device on your cell phone. So nothing is perfect. Let's just get that out of the way. Let's see an example of that. I don't know if anyone has ever tried this, if they're not into Android development, but I encourage everybody to at least try installing this tool, and it's the Android Debug Kit. If you have an Android phone, and simply run this one command. You enable USB debugging. Every phone is different. I know you can tap about a couple times and boom, you have USB debugging. So logcat. Let's see what happens. This astonished me. This is a device that I made, and I was kind of doggy bagging it, as was said in Microsoft, which is you create something, you use it yourself to make sure that it works, and then you catch all the bugs before it goes out into other people's hands. So I installed ADB, Android Debug Bridge, and connected my cell phone to this device. And what I saw was that after powering down the device, device looks like it's off, but you can see the messages just scrolling by. And it's like, if I turn my phone off, I expect it to be off, but it's not. So what is it doing? Well, it's doing everything normally. It depends on, what brand of phone you have and who packaged the version of Android and what kind of apps you have installed on your device. But generally, this device was pinging up location data, Wi-Fi data, and who knows what else, while still connected to the network. But again, the screen is off. So this has been said as a part of design philosophy is don't optimize what should not exist. Well, what should not exist? Well, if I can make something better, one way to make it better is to make a version of a new device. And I want to take one part, remove that part, and I don't have that part anymore. So if I had 10 parts in the first version, and the next part I remove one, I have 9 parts, and I've saved money, hopefully. And this is how that happens. This is taking place off the subway stop in Watchung Bay. And I'll go into what Watchung Bay is. This is, I kind of call it a casino, because it reminds me of a smoky casino that I saw when I was younger, when vacation with my parents, and there's just smoke everywhere in this little unventilated corner on the side of the subway. And what happens there is fascinating. There are halls of old devices with parts that may or may not have been already removed. These are motherboards for cell phones. What happened was the CPU and the storage was already removed, but these boards still had parts on them. Still had parts such as a chip for power management or a chip for cellular connectivity. So there's still goods that could be taken from this, and that's exactly what happens. Sometimes here in this small little location in the markets, you see people with hot plates and hot air guns remove BGAs and all sorts of components and repair them right there and then resell them. Some go through a testing process, and you have to have your own testing process if you want to reuse these parts, but the capability is there. So everything that's being created is also being destroyed. And then there's a product development lifecycle mantra, I would say. It says cradle to the grave. If I'm going to design a product, I want to see how it evolves and what happens after it leaves the customer's hand. I like to think it more so as cradle to cradle. So this is boards that still has some value in them, and we can take these parts and put them into a completely new design. And depending on what failure rate you're able to accept during manufacturing, you can still use these good components, but had just been used previously under unknown conditions. So my friend that I met that day actually helped me take these photos, and he was just astonished. That's his feet here. This was taken last week in the markets. And they're different piles. So that pile would have certain components missing, and that pile would have other components. So how do we create? Well, most times, many people in this room probably use JLC or PCBWay. Those are in the Greater Bay Area, and this is Watchung North, or Watchung Bay. Watchung Bay. And I actually just learned this recently. I'm not formally trained in Chinese, but Wa, the first Chinese symbol, means magnificent. Chang means a force or strength, so a magnificent force in the north. And that's Watchung Bay or Watchung North. And what does it look like? Well, this seems to be a recent photo. I've been here for the past 5 years. This used to be a street that ran up and down this part of the markets. And this was so dangerous that they turned it into a walking street. And now they have food trucks along here and different activities. And if you see on this side of the street is Wachang, or HQ, owned by one company. And this side of the street is owned by SEG, the Shenzhen Electronics Group. So this whole street down and this street down are owned by separate companies. And there are things you can find all over here. This is 8 floors of everything. As you go up, you can, every part, replacement parts for every kind of computer and refurbished parts. Factory direct locations are on the main floor here. And then over here in the SEG, which we're going to turn around and take a look at, this is the tower, SEG Tower. This, if you walk in here, when I first walked in there, I was overloaded. It was like TMI. It was too much information. My brain had to get some rest before I could take in more. But after months and months of every single day walking through these markets, was I able to understand and generate a mental map of where vendors are. This is actually an old photo. The antennas on this building have been removed, so that's how I can tell. And this is SEG Marketplace. This is the first floor. Again, an older photo. This is much different. But a lot of these vendors are still there. And you can buy Arduinos and little kits. You can source components. Everything is here. And this goes up, floor by floor by floor. Everything that you could possibly imagine right there at your fingertips. This is Kelly. I'm going to show you some photos of people that are my friends, and that have helped me tremendously in learning about how business is done in China, as well as teaching me Mandarin. I call Kelly, she's the owner of this shop, I call her my Q. Kind of like James Bond has a Q for getting the latest gadgets. Kelly always has the right screwdriver, and if she doesn't have it, then she knows someone who can run and give it to you in 10 minutes. So forever grateful for her help. This is Sam. I kind of just walked in on Sam. I said, hey, Sam, I'd like to show people your workshop. This is in the first floor of SEG. And he's just in this little cutaway. And all he's doing there is replacing components on any sort of MacBook or Apple products to make it work again. And he went through and he showed me. He said, hey, these components, these footprints on the PCB are missing pads. So I'm replacing the pads, and then I'm going to resolder the components back on. And this is one of the latest Apple MacBooks. And you can see kind of a little bit of the damaged pads. Sam, I was very grateful. He taught me. He teaches me, and I teach him. And it's incredible that they're able to fix and upgrade things that we are told are not able to be upgraded or fixed, because the resources are available. It's just the knowledge is very not well shared. This is one part of the market. This is an HQ, so this is in a separate building. That's the one on the left. This is my business partner who does PCB reverse engineering, PCB, and also PCB copy modification. So if you have an old circuit board, the engineer may be retired 10 years ago and there's no information on it. What this company does is take any PCB, whether it's 2 layers or 10 layers, and they will sand it by hand and scan each layer so that they can rebuild the circuit board into not just a Gerber file, but also the design file. And in this case, and again, she's, her company and herself, she's incredibly knowledgeable about PCBs and the construction. And I'm so grateful that she has taught me everything that she knows about PCB deconstruction techniques and why things are more expensive or take more time. But these services are available if you need to learn about something or replace something that the engineer is no longer available to help fix for you. This is a different part of the market. This is a communications market. And this company is great because they have fixtures here for every single part on different phones. So if you have a touch sensor that's broken, you want to reconfigure the battery IC, you want to test displays, you want to, nowadays, cell phone PCBs are sandwiches. So this is out of a Samsung Fold Z1, I believe, and it's 3 PCBs. And this is how the latest cell phones today are built. It's not just one PCB, but multiple PCBs stacked on each other. And what they have are hot plates with a fixture that's designed for just one PCB so that you can remove those inner pieces of the sandwich and take the PCB apart. This is another friend. He helped me on a Sunday evening at 6 p.m. The markets were thriving. Money was in the air of just people buying secondhand phones, broken phones, repaired phones. And this is just a very small part of the market. You can get lost there for a week and still not discover every single part of it. What my friend specializes in here are FPCs for cell phones and also other smaller circuit boards that I'll show you in a little bit. So I had originally set out to fix a Samsung phone that is a Fold, and I bought it for 300 renminbi, which is $45. And I said, oh, great deal, new phone, $45, just need to replace the display. But then the display cost $300, and even in China, that's too expensive. And it's because these displays have a 1-year life cycle, and they will eventually break, so you'll need to replace it every so often. So I instead built a Mate 10 Pro, and this is actually one of the last phones built by Huawei that was sold in the United States before there were sanctions against Huawei. So I wanted to see how expensive these parts were. So you have basically this back cover with the sticker on it, and that has the fingerprint sensor as well as some lenses, the battery, this kind of shield, which we'll take a closer look at, the main board, which has its what we call maozi, or hats in Chinese. Those are the RF shields. The RF shields or the hats have been removed. You have 2 cameras, as well as that little tiny PCB up there that we're going to dive into. There's a lower shield. Then there's a connection here with a small RF cable. And this is the speaker, as well as this separate microphone PCB that fits down here. And then the display. So there's other miscellaneous parts, but that's pretty much it for this phone. That's what makes up the entirety of it. And if you dig deep down into the cost of these goods, this you can buy for $1.50, $3, $1 for the back plate, main board $15, FPC $1.50. Same thing with the back camera module, $1.50. I said, hey, I need this camera for this phone. They said, okay, which one? There was just a booth with just bins of cameras, used cameras, and they take a bin out and they put it on the table, and there's maybe 200 cameras, camera modules from a 2018 phone for $1.50. I think it's incredible that this technology is available for so inexpensive. What's really preventing its usage is the lack of public knowledge, and a lot of it's hidden away under proprietary data sheets. So let's take a closer look at the main board. You actually have 3 chips here. This is the CPU, as well as the LPDDR RAM on top. This is the memory storage. And then over here, this is what's in most cell phones, and probably most cell phones that you have here today, an NXP semiconductor secure element for NFC. So this is also, one version of that is used in iPhones and MacBooks as well, or used to be, with the T2 processor. That was in 2018-ish. Now things have changed dramatically. But this is actually from iFixIt, this photo. I'm not sure what happened to the attribution, but iFixIt really doesn't give you the full picture. This is their full description of what's the parts on this side of the board. And there's 2 things here. There's a hat here, a Mauze. There's a hat here. And then the camera module goes into the center. So I actually wanted to see what else lied in there. And I popped the hat, and underneath, actually in doing so, I knocked off a component. It was a BGA. And I went to the markets and I got 10 pieces, a strip of 10 for $1 each. And also, at the same time, I noticed that there was a component missing, and I'll come right back to that. Let's just take a quick look at the back side of it. Again, here's another hat. iFixIt doesn't give you any information on that. This is the old power management power section, because the CPUs are on the opposite side of this board, so it needs a tremendous amount of power and capacitance here. You can just tell by looking at it. This is the Wi-Fi chip, a Broadcom Wi-Fi chip that's connected over PCIe. And then over here is mainly just cellular connections, and you can see the antennas. This is some, and then here is an audio codec, and then on the upper part, right there are sensors. There's a microphone, and this connects to the camera module. This is the battery connection here, and this connects to the FPC to the bottom to connect to the USB-C connector. And you can also see the comparison between iFixIt's photos and my own. They had actually cut away some of the RF shielding to get a better look at the picture, get a better look at the components. So yeah, let's go back to this and say, okay, well, we understand what this is, and I just need to understand what's under here. Let's deconstruct it. All right, I popped the hats, and we took a deep dive. It looks like it was like a 10-layer board, buried in micro vias, laser drilled holes, very complex technology. To completely reverse engineer this board would take about a month time, and at the end result of it would be a PCB design file that you can load into Altium, modify, and then have made, which I think is so powerful in what you can do, because this is not only for cell phones. I want to remind everybody this same technique and process can be applied to any kind of device. If you want to dissect it, the deliverables are, I'll go right into it. So this is the speaker board. There's 2 microphones on the bottom of this cell phone, and these microphone boards are about $1 a piece. This is a scan result that I got back. This is the first step of the reverse engineering process. Top and bottom scans. You can see that this is a new PCB because the microphones are covered with some tape here. These are all pogo pins, and many times if you don't have a manufacturer that already creates them, they can open a mold and make these custom for you identically. Of course, there's some fees involved in that, but realistically not unattainable by small companies, private companies who want to do this kind of reverse engineering so that they can learn more and improve and make their products better. So the deliverables, I get a PCB design file, Gerbers, a BOM, a bill of materials, and also a schematic if I so ask them to do so. The BOM looks like this. You don't get a full teardown of what the components actually are. It's not that deep. You just get the markings. And then all of this, all these capacitors here and resistors, these are inductors and some other miscellaneous. That's all measured with an LCR meter. So with a couple $100, you can use an LCR meter and get the value. Just remove one part, one by one, get the value. And within certain range, of course, all components have tolerances, whether it's 1, 5, 10, 20. You can pretty much, with high degree of accuracy, determine exactly what value those resistors, capacitors, and inductors are. So this is another scan result that I get back. These are all designators that the company provided. I didn't provide any of this. And this corresponds to what's in that bill of materials. This is the opposite side, again, part numbers. This is where the speaker board goes, and you can see here it connects to certain parts of the chassis internally. This is a CNC'd aluminum case, and then it's overmolded. So they take this CNC blank and they put it into an injection molding machine, and then they inject plastic over it so it becomes one piece. And inside of there are antennas and other sensors. So let's reconstruct. These are all chassis, and they cost about $3 or $4 depending on what make and model you're looking for. And this will allow you from, I like to think of it as like if you were to strip down a car to its bare frame and then build it back up, this is the car frame, which is the equivalent for a cell phone. And then of course, screws. Any screw type. The phone I selected has one screw type, so just one bag. And these are infrared and ambient and light proximity sensors. It's kind of like a module, a separate module that allows the sensor to get closer to the display, and which goes through the chassis. This is an RF shield that goes above the main board. And one of the things I noticed is that there is a China and US version, and the Chinese version has these stickers, and these are antennas. There's one up there, that's a Wi-Fi Bluetooth antenna. This is a diversity antenna for cellular. And then one over here is just LED lights for a flash. And those are stuck to this, again, overmolded piece of aluminum that has this plastic fixed permanently to the metal. This is something I learned quickly, and I always learn something by speaking to these vendors. This is an extension cable that allows you to take two phones and set one on top of each other, and you can test the screen in one of the phones. So this is just the chassis and the LCD, and then there's nothing else in it besides parts that are stuck to the frame. And if you want to test this, you just connect one of these FPCs, which cost $1 or $2, connect it here, and then you can lay this on top of another phone and test the functionality without having to rebuild the whole phone. So it's a kind of makeshift test fixture for LCD displays. One thing to note is that if you buy spare parts for cell phones, whether it be here in the US on eBay or anywhere else, you may find markings like this. These indicate who sold you the part, so that if there's an issue with the part, you can go back to the vendor and bring it up to the boss pretty much, and explain to them why this part is bad or why this part needs to be different in some way. And also if the part's totally bad, they can give you a refund. They know that that's their part because of the stamp. This is a Huawei engineering cable, $1.50. Inside is just 3 resistors, and this will allow you to get into the factory bootloader to reprogram the phone. This is a USB serial, a product on Crowd Supply, and this uses buried vias and micro via technology, which you can't make on JLC. I made a version without the buried vias, and I would like to soon speak to the creator of this and share that because it is open source hardware on their repository, so anyone can make these if they want with JLC. These are just, again, motherboards, scrap motherboards. They cost $7. It has most of the parts on it. But I did notice this, and this is a switch. There's debug UART on top, and then some other signals. So this takes single pole, double throw, so it takes 1 input, puts it in 2 places, or 2 into 1. These are test points on the motherboard. You see this boot mode test. And then this connects directly to the processor, and it has more test points here. So you can get into modes on these motherboards that are not commonly available. Everyone was given a badge, I believe, as they came in. Badges have generally standard add-ons, and you've seen a whole display over there. This is kind of like a standard add-on for a phone. I'm just going to quickly go through this. This has just an infrared LED. The top 2 pins are connected directly to the LED. There's power and ground. So 2 GPIO, power and ground, and then I2C. And these are the proximity and ambient sensors. So it's kind of like a module or add-on you can replace inside the phone. You see right here on top, it plugs into the main board through these pogo pins. This is the connections, and you can see it matches the number of pins for the add-on, but in a different orientation for badges. And then this is the reverse engineered files that I got back. This was pulled from Gerber files using GerbV. And these are the internal layers. You can see the I2C here, connect to the 2 sensors. This is a 4-layer PCB with buried in micro vias. I don't know why. But these are the bottom 2 layers. And then this is the top. And you can see it's connected to the infrared LED, and everything's connected to I2C. So thank you very much for having me today. This world is a deep journey, and there's so many places to take deconstructing PCBs or making products, and you can endlessly talk about these things, but I just wanted to share this world that's happening right now. They're waking up in China, in Shenzhen. It's the weekend, but many are still working. I just want to remind everybody that when you're ordering something online, please remember, people working jobs and they want to do their best job, and if they don't understand, please take the time, if you can, to just share what may be wrong or how to do things better, and they really appreciate the feedback. So thank you very much.